And we will have a comparative discussion on these three most important bibliographic databases that are important to us. Let me give you a comparison first. So in terms of coverage of the journals, you can notice that Google Scholar, which is shown in green, covers a large number of citations compared with those by Scopus and Web of Science. And which is, I think, understandable, because Google will cover everything that is published on the internet. On the other hand, Scopus and Web of Science, being scholarly databases, they only consider things which are published in scientific journals. So the number of entry in their databases are obviously small compared with the Google Scholar. So that is the first thing that you see. The second thing that you will notice is that in social sciences, Google Scholar have more coverage compared with engineering, for instance, and computer, which is again logical because normal people don't deal with engineering. So in social media, on all other platforms, you see more contents on social sciences than engineering. In some discipline, it is even more clear. So if you talk about finance, then Google Scholar will have a lot of entry compared with Scopus and Web of Science. Whereas if you go to very specific topics like chemical kinetics and catalysis, so you will notice that Google Scholar actually doesn't have not much greater number of citations compared with the Scopus and Web of Science, because you don't see many things about chemical kinetics on the social media. So whatever Google Scholar includes, these are mainly those journals that are cited or indexed by Scopus and Web of Science. Now, coming back to ISI, it stands for Institute for Scientific Information, founded in 1960. So their purpose was basically to analyze the bibliographic data. And currently this is owned by a company called Clarivate Analytics. So ISI now have this Web of Science databases, which is very popular. However, this web, get access to this, you need to subscribe, and the subscription fee is quite high. So I'm not sure if BUET library has any subscription to these databases. Maybe we need to explore this. So under the Web of Science databases, which is available on the internet, I have three main sub-databases. So one is Science Citation Index, which includes about 13,000 journals. Social Science Citation Index includes about 6,600 journals. And the third one, Arts and Humanities, include about 3,000 journals. Now, as a researcher in engineering, you will be most concerned with this group of journals, Science Citation Index. However, those who work in area which is at the cross-section of science and social sciences, then some of the journals included in this second category, you may also be involved in those. In Web of Science, we have about 21,000 journals, as I mentioned already, and it has total citation of about items, which means the total number of papers, about 65 million. And the citation that there is about 1 billion plus. It's a huge, huge data set. In the Web of Science, in addition to the journals, so these are basically journals, Science Citation Index, Social Sciences, arts and humanities. They also have started putting data into their databases from conference proceedings. Because this Clarivate Analytics is basically a business entity, so they want to expand it to get more profit, of course. So conference proceedings are now also included in Web of Science as Conference Proceedings Citation Index. And they have two types. One is for science, another includes both science and humanities. In addition, they also have this database for books. So earlier this was not present. So the citation was only for scientific journals. Now books are also included. WOS has certain criteria by which they include the journals into their databases. And it is recognized that their category, their criteria are the most stringent out of the three that we are considering now, which are obviously Scopus and Google Scholar. So these are some of their criteria. So the publication must be published in a timely manner, and they must conform to the editorial convention. So this must be a professional work that they are doing. It must be published in English. So WOS doesn't include any journal in any other language. Of course, they will look into the content, the quality of the content. In addition, they also will seek they will look into whether there are international diversity in the journal in terms of authors, in terms of editors. They will also do the citation analysis themselves, and the history will be taken into account. And based on all these criteria, they will select or reject a particular paper. And this is an annual process. So if a journal is not performing well against this criteria this year, then they will be dropped out of this next year, and so on. And if there is another journal which is performing better, then they will include this into their database. And they will publish now the analysis that they make out of those data they collected from the journal. And one of the most popular analysis is given in this journal citation factors, journal citation reports. And in this report, you will see the impact factor. And if you haven't heard about it, I'm sure in the coming months, you will notice that this word is very important, impact factor. Just keep that in mind. Now, this is how it processes the data. So because everything is digital nowadays, Scopus will collect all article level data for science, social science, arts and humanities, which means that it will collect the data of the author, the title, the abstract, the keywords, and so on and so forth, the references, the citations, everything will be collected and then analyzed. And at the end of this analysis, they can give the result in many different forms. Like they can give the result in terms of journal level data, researcher level data, institution level data, like how BUET is performing in publication, they can easily give. How a country like Bangladesh is doing, how a field or discipline is doing. And all these data are useful. There are people who are willing to buy this. So that is why they are doing it. So they sell it to different libraries, to universities, to ministries, to different organizations, and so on. So this is how they make money. And you will probably also hear this word if you haven't heard about it, research impact. People will ask you, you are doing research, so what? What is the impact of your research? So of course, the answer to this question is not given in this cartoon. Just to tell you simply, in order to claim that your research result has achieved certain impact in the academia, you have to use those matrices like impact factor, H index, etc. And that is what we are discussing. So it is nowadays considered that impact factor, H index, etc. can give a representation of the impact that your paper, that your research have created in the academia. So just remember this, in the academia. But of course, impact can be outside academia. And that is not the topic today. We can discuss it another time. So impact factor, H index, these are the matrices which are important for us, because nowadays people widely accept this as a measure of the impact that our research work have created. Now I have a question for you. Which one of the databases do you think includes the highest quality publications? Any answer to this?
Sir, I guess the answer is B.
Which one? A, B, or C?
Sir, it's B.
B. So I have an answer. Any other answer? Anybody else is brave enough to give you answer? If not, I will do is this. Let me go. I can also just see whoever is there. So I'll ask one of you. For instance, Adnan Adi, what do you think? What is your answer, A, B, or C? Adnan.
So the answer is B.
B.
Yes, WOS.
Okay, all right, you are correct, I think. So obviously WOS is considered to be the most prestigious web databases. Can you still see my screen?
Yes, sir.
Yes, okay, let me proceed. So now we will see how this impact factor is calculated and what is it really. One caution, impact factor doesn't have answers to every question, and it doesn't really give you the complete picture about the quality of researcher or paper, whatever it is. It is one of the matrices. If you really want to find the research quality, you have to look into other things as well. This is the inventor of this citation, the concept of citation, Dr. Eugene Garfield. I think he's from UCLA. So in 1955, he first developed this, and he started this ISI, the Institute of Scientific Information. And in 1963, he developed this multidisciplinary science citation index. Now let me explain how this works. So all of you have been reading numerous research papers. So this is one example. This paper is written by Laws and co-worker. So Laws et al. Are the writer. And during writing this paper, they based their paper on the knowledge that was created by previous researcher. So they cited a researcher with the name of Lilly. So Lilly and others wrote a paper and they cited this Lilly et al. Now, Lilly et al. Can claim that since Laws et al. Has cited my paper, that means that my paper is important, and she can claim that this paper has some impact. So that is the assumption, and that is how things work. So if your paper is cited by others, then you can consider that your paper have created impact. And of course, at the end of it, you have a list of papers. So all these authors can claim that their work is important because somebody have cited, like Les or Eol has cited their papers. So based on this concept, the impact factor is calculated. And journal citation report in WOS, they will show the impact factor, the journal. Now keep in mind, impact factor is designed for a journal originally. And this is how it is calculated. Let's say a journal has been publishing papers for the last few years, and some of their papers in their journal has been cited by other people, other researchers, other journals. And if you can keep track of those citations, then you can find out the impact factor from the definition that I'm giving you. So this definition of impact factor considers the quotations or citations that a paper receives, a journal receives in the previous 2 years, immediate 2 years in the past. So if you want to measure the impact factor of your journal in 2009, then you have to see how many papers were published in the last 2 years, which is 2008 and 2007, and how many of them received citation in 2009. So that is the data that you need to find out the impact factor. So if you put it in this formula, so impact factor of this journal is the number of citation in current year to items published in 2 previous years, divided by number of articles and reviews published in 2 previous years in that particular journal, which means that this is basically the average citation that a paper receives in that journal. It's just the average citation received by a paper based on the last 2 years citation. And you also have to keep in mind that this impact factor is for a journal. It's not for your paper. And if you open different journals' websites, so you will notice that they will proudly display this. The impact factor of this journal is this and this. By the way, when it is impact factor, normally this is patented, and Clarivate Analytics, this WOS impact factor, that is something that is understood. So impact factor means WOS impact factor. However, you have now, after this WOS, other entities who also calculate impact factor. Like Scopus also calculate impact factor based on a slightly different formula. And Google Scholar also calculates impact factor of a journal. Okay, now let me go through this process, how we can calculate the impact factor of a journal. Let's say we have a journal which has been in publication for the last few years, and we are now in 2009. We want to find out this year, which is 2009, the impact factor of our journal. For that, we have to consider the last 2 years. So we have to consider what are the publications published in this journal in 2008 and 2009. And we have to use that data. So we calculate the number of sites in 2009 that the items published in that journal in the previous 2 years So we need to calculate the total amount. And in 2000 journals, the articles published in 2008 received 423 citation in 2009. Articles published in 2007 received 755 citation, which is obvious because it was published earlier, so it has more time to collect the citation, and the total is 1178. Now, you also can find out how many items were published, how many papers were published. In 2008, the number of papers published were 164, and in 2007, it was 235. So you have 399 journals. Now, according to our formula, the impact factor is cites to recent items, which is obviously for the last 2 years, and the number of recent items. So 1178, the sites and the number of items. So it is now 2.952 for this particular journal. So this is how it is calculated. So obviously you notice that this impact factor basically tells you what is the average citation each paper in this journal gets. So that is what it is.
Sir, I have a question.
Yes.
Sir, what is the standard value of a quality journal? The impact factor.
Ask me this question at the end of this. So probably you will get out of the answer when I move forward. Just wait for a moment. Scopus also have this, and they have the site score, SciMago journal, and then source normalized impact factor, but I don't think I have time to go through them. But they also use similar methodology, slightly different. So they use, I think, 3 years instead of 2 years by WOS. I have a question again. So which one of the following is applicable to impact factor? There are 3 answers. Give me the correct one. A, B, or C?
So C.
One, so tell your name. When you give an answer, please introduce yourself. Just name will be okay.
Sir, Rashid. So
Rashid.
answer is C.
Right answer is C. And any other? I want one more answer, at least one more. I see.
Answer is C.
Salman is also telling it's C. Yeah, you're right, it's C. So that means when you publish a paper, you cannot claim that your paper has an impact factor of so-and-so. What you can claim is that I publish my journal in an impact factor, in a journal which has an impact factor of, let's say, 6. Then you can claim, since I published my paper in a journal which has high impact factor, then I can assume that my quality of my paper is good. So that is how things work here. So we cannot claim that our paper has high impact factor, but what we can claim that we publish it in a journal of high impact factor, and by default, then our paper is of good quality. Next is journal quartile. And journal quartile, I'm not sure if I should go into detail. Let me think. I'll do it quickly. This is also based on impact factor. And I'm not sure if this word are familiar with you. So people talk about Q1 journals, quartile 1 journals, quartile 2 journals, and so on. Now let me explain how this is calculated in WOS. But before that, I have to give you a little bit of explanation of this WOS. So if you, this screenshot that you see is a little bit older, but I think the basic principle is still the same. So if you go to Web of Science, then you will have the ability to look into the data of a particular journal. but of course it costs money. For free, they give a little bit of data, but in order to get the full, let's say, data sets, then you have to subscribe to these databases. Anyway, so what you see is that in this website, you will see a tab for journal citation report. And the journal citation reports is very important because it gives us the data which are useful to us as researcher. So when you click this, it will show you a certain screen, and from that screen you can go into the database that will show you the impact factor. For instance, you can start from the basics, from the category, because they will divide the whole science domain or knowledge domains into different categories. And then they will calculate the impact factor within those categories. I have to emphasize that, and I will explain. Now, this is how they divide the whole domain of knowledge. And then they will put them, arrange them alphabetically. For instance, they will start, let's say, with acoustics, and then there will be agriculture. Engineering will have different sub-disciplines like engineering, electrical and electronic, engineering, mechanical, and zoology, and so on. And under each category, they will have journals in their databases. So I will take a random example, for instance, electrical and electronic. And under electrical and electronic, they have 247 journals. And of course, it's an old data, but it's good enough for our understanding. So in electrical and electronic, we have 247 journals in this category. Now let's have a look. So when you go and click the right button in electrical and electronic, then it will display the whole list of journals under this category, again, starting with, let's say, acoustic, and then agriculture, and so on. So, sorry, this is about the category, the whole category. Now, in the whole category, if you scroll down, you are interested in electrical and electronic. So you click, and then you press the button, then it will lead you to the electrical and electronic engineering category page. And you, of course, you have to submit. So it will lead you to this page where these 247 journals will be listed in this page, starting from the most high ranking one in terms of impact factor. So typically they will display it in terms of impact factor, but you can change it if you want to arrange them in terms of total citation or any other score, and that can be done. But for our purpose, I think that's sufficient. So it will arrange them in terms of impact factor. And obviously what we see is that number one has the highest impact factor. In this case, it happens to be 6.524. And if you scroll down, then you will see the last ones, 247, 247. And the last one gets about 0.02 impact factor. And they also included some other journals, 2 journals, which didn't yet get their impact factor. So they are being considered now, they are included, but they will get probably the impact factor next year. So you see, things are arranged according to the journal impact factor we can do. And you also notice that the first paper, sorry, the first journal, IEEE Wireless Communications. So this is number one in this category because it has the highest impact factor, 6.524. If you click that journal, IEEE Wireless Communication, then it will lead you to a page which will look like this. And you will notice that this particular journal is also indexed in 2 other categories. So if you look at it, so it is indexed not only in electrical and electronic engineering, it is also included in 3 other: computer science, hardware, etc., computer science, information systems, telecommunication, and so on. And the position of this journal in each of these categories will be given. So if you click the right place, you will notice that it gives you the data for this journal within this computer science and hardware and architecture category. So it will also show you the impact factor as a function of year. So it's a little bit old, but you can still see this. In fact, this arrow should go in this direction. And you note that in 2013, this particular journal, IEEE Wireless, so this is #1 out of 50 journals in this category, and it mentions here Q1, and I will explain what this Q1 is. So you get all the data for this journal in other categories: computer science and information systems, electrical and electronic. Again, in this category, it is #1. There are 248 or 47 journals, and then it is Q1. So how does it determine that it is Q1? So that may be your question. Again, I want to remind you, so this is how things are arranged in the databases. So Science Citation Index will cover all science domains, science and technology domains. They will arrange them alphabetically into categories: acoustics, agriculture, engineering, electrical and electronic, engineering, mechanical, engineering, materials, and so on, zoology, etc. And under each category, they will include a number of journals. So this is how things are. Now let's go and see how this quartile is calculated. So basically, we are now considering our journal, IEEE Wireless Communication. And when we click them, we see the position of this journal. And I think I'm going a little bit detail. We are not considering this. We are considering engineering, electrical and electronic, basically. And in that category, we have these 247 journals. And IEEE Wireless is #1. So this is the whole list. The whole list is coming from 1 till 247. Now you can divide the whole list into 4 sections, equal sections. And then when you consider the top 25%, of course, this list is based on this impact factor, journal impact factor. So the top 25% is called Q1, quartile 1, then quartile 2, and so on. So you can claim that journals whose name appear within this Q1, they are the top 25% journals. So obviously, as a researcher, if you are in this field, your aim should be to target in journals which belong to Q1. We encourage all our students to have this ambition to target journals within the Q1 in their own category. And remember, this list is valid only for this particular category. And the answer, the questions that some of you asked, that what is the impact factor, standard impact factor for a category? In fact, there is no standard. What we notice rather is that impact factor is dependent on the category. There are certain categories where the impact factor is inherently high. For instance, life sciences. If you are a medical doctor, you publish in life sciences journals, or a biologist published in medical sciences journals. Those journals have typically high impact factor compared with, say, mathematics. And there are reasons for this, because these life sciences are very well funded. There are a large number of researchers, large number of journals. They publish more papers and so on. So they get more citations. On the other hand, mathematics, this community is very small, and the funding, research funding is very small, fewer research projects, fewer publications, and fewer citation. That is why you have fewer number of, that is why the impact factor is less. So that means you cannot compare from one category to another, this impact factor. For instance, if you are a poor mathematician and you publish your journal in an impact factor of 0.5, and if your friend who is a medical doctor who is publishing in a journal where the impact factor is easy to get impact factor 10, these are all things. Then if he comes to you and says that your work is very poor, you cannot publish in high impact factor journal, then there is no reason for you to be disappointed. You can then argue back. You can tell him that, look, in your case, it's inherently the impact factor is high. In my case, its impact factor is low. So even if I publish in 0.5, it's still probably better than your journal, because in your case, perhaps this 10 is at the lower end. So that should be the response of this mathematician. Anyway, so since the impact factor varies from category to category, it's difficult to compare them directly. There is a rule of thumb: if the impact factor of mathematics is 1, then an equivalent journal of similar quality will have an impact factor of 10 in medical sciences. So that is the rule of thumb. That is why there are some indices where the impact factor is normalized with respect to the category, but that is a slightly complicated calculation. I will not go into that today, but if you are interested, we can discuss it later. So for engineering, you see, it's again dependent on the field. For instance, chemistry, chemical engineering, they tend to have more impact factor compared with, let's say, materials engineering. But things change from time to time. I'm just giving you a rough idea. So the message that you get, that you cannot compare impact factor of journals in one category with impact factor of another category of journals. Impact factor of 3 different types of papers. I think we discussed yesterday that there are 3 different types of paper. One is full-length paper, another one is letter or short communication, another one is review paper. If you look at the trend of citation, normally the letters will receive a large number of citations at a shorter period, because letters are published with latest publication, latest results. So that attracts a lot of citation or attraction at the beginning. But it is not sustainable because the information is quite small there. Compared with this, a full paper citation rate may not be high, but it lasts longer. Its half-life is longer. So you can get overall larger number of citations for a full paper. On the other hand, review paper, if it is very good, it can receive a lot more citation. So that is why there is a trend that many researchers nowadays also publish review papers in addition to their research paper, experimental paper. Another question. Which one is used to calculate journal quarterly? So you have to give your name and then give the answer.
Sir, I guess the answer is C.
Answer is C. Let me put this. I want to get some more answer. What is your name?
Sir, my name is SAM Sabir Hassan.
Sabbir. Okay, Sabbir, thank you. I want a couple of more answers.
Sir Rashid,
Rashid,
the answer will be A, impact factor only.
answer is A. Okay. I want another one, the last one. I have to select. Abdullah, can you give me the answer? Abdullah, are you there?
I think the answer will be A.
Answer is yes. Abdullah's answer is also A. I think they are correct because the journal quartile is based on the impact factor. So if I take you back, let me take you back. I don't know. I think I see something, a ribbon in my screen. And I don't know how to remove that. Anyway, so if you look at it, so to calculate the quartile, you need to arrange the journals according to the journal impact factor. So the highest one will be at the top and the lowest one will be at the bottom. And then you divide them by 4, and there you get the top 25% as Q1, and then next 50%, top 50% Q2, and so on. So this is the way that we calculate. Thank you. Let me now go back. Take my ribbon up. I cannot move the screen. Okay. I think we are done with quartile. Well done. Let's go to H index. H index was discovered by George Hirsch. So he's from University of California, San Diego. And he was trying to get one single metric that will describe both quality and quantity of a researcher. So one single number. And in that quest, he proposed this H index. And H is coming from the first letter of his last name, Hirsch. It is also called Hirsch index or inch. And he published it in 2005, in fact. And this is very popular nowadays. So let me explain what it is. So Hirsch wanted to get one single number that will give us the quantity and quality of publication of a particular researcher. And nowadays it's very popular and everybody calculates H index. Obviously, Web of Science has H index, Scopus have their own H index, and Google Scholar also have H index, which is free, in fact. For Web of Science, I think we need to pay. For Google Scholar, so it's totally free. Now, this is the definition. A researcher has H index of H if H number out of his total N articles have received at least H number of citations each. And the rest of the articles, N minus H, have received no more than H citation each. So that is the definition. Now, if you are puzzled, don't worry. When I read this definition at the beginning, I was also very confused, but I'll try to explain to you. So let's say we have this data for one author. So he published 8 journals. Where is my... Okay. So he published 8 journals, and we know the citation that each of the journals have received. So in order to find out his H index, we have to arrange them in this form. So we arrange them in terms of decreasing citation number. So number 1, the first journal is the one that has received highest citation, and so on. And the last one, 8, received the lowest citation, 4. Now, according to this definition, so his H index is H if H number of his publication receives at least H number of citation. And here, this 6 satisfied this. So his H index is 6 because 6 of his publication received at least 6 citation, and the rest received less than 6 citation, 5 and 4. So this is how it works. And you can, of course, graphically calculate this. If you put citation on the one hand and the number of papers on the others, and then you draw a line at 45 degrees, then you can see that this is the H index. So I have a question for you. So we have a scientist and he published 11 papers. We call them, let's say, docs. He has 11 documents, 11 papers, and we put them number 1 and 2 in terms of this decreasing citation that he received. The first one received 49 and the 11th one received 0. And my question is, what is the H index for this particular scientist? What do you think? Don't worry if your answer is not correct. My answer was also incorrect when I saw this first.
Sir, I think it will be 5.
So what is your name?
Abu Bakr Siddiq.
Sorry?
Abu Bakr Siddiq.
Abu Bakr, okay. Abu Bakr, you are telling that this is fine. I just put down. I want a couple of more.
Sir, I think it's 5.
I have another one. Who is it?
Sir, I'm SM Sabir Hasan.
Sabbir, okay. The last one. Don't worry. Just give me a number. Let me go to the chat. So Naeem is saying this is 5 again. So I got one from Naeem. Jannatul Naeem. So I got it 5. So let me show you. In fact, you are correct. So it satisfies the definition. So 5 number of papers received a citation, at least 5 or more. So here it is 6. So the H index of this author is 5. I have some more examples. About author A, what is the H index? Which is, I think, very simple.
Sir, it's number 5.
Number 5, so simple. About author B?
Sir, I guess it's number 4.
Any other answer? One more answer.
Sir, author A 5, author B 4.
So author B4, yes, you are correct. Very good, well done. So once you start publishing some papers, then you will see that your H index will also appear on Google Scholar, which is free, of course. So one last example. What is your answer? I did not have it.
Sir, Article 5.
Okay, so cite H index. Give me the H index.
Sir, Article 4.
H index. So you have to tell,
Article.
not article.
Article.
You have to give me the H index of this author. So this problem is there.
5.
So one of you is telling it's 5. So I'm writing it down.
I think the answer is 4.
Sorry,
I think the answer is 4.
H index is 4.
Yes.
I have the answer. I need the last one. Who can give me the last one? In the chat box, I think I have probably, again, Jannatul 9 is telling it's 4. Adnan is also telling it's 4. So we have few others telling 4 and 4. Yes, you are correct. The answer is 4. Because there are 4 papers which received at least 4 citations each, and the rest received less than 4. Am I right? Yes, the H index is 4. Yes. Okay. Now, this H index, although it was developed by Harsh for researcher, but now people find it very useful. And people see that it can be used for other purposes also. So it can be used for an institution. For instance, BUET can claim that the H index is this. They use the same formula. And then even NCE department can also claim its H index, or it can also be for a journal. So nowadays it is used not only for individual researcher, but also for others as well. And do you know these people? How many of you know these 2 gentlemen? Professor Wheaton is theoretical physicist. Professor Stephen Hawking, theoretical physicist. But how many of you are aware of the left one or the right one? Anybody knows before Professor Wheaton or Stephen Hawking?
Sir, Stephen Hawking always.
you know him. So you know him because he's probably the best scientist of our time. And everybody knows him. Whereas Professor Wheaton, he's also a good scientist. He's a theoretical physicist in the same field. But if you ask the people on the street, nobody knows him. Although his H index is very high, double compared with Stephen Hawking's. But we know he's one of the best scientists of our time. So you see that H index cannot always tell you the correct picture. So in academia, H index is important. It can tell you something, but then you need to have some other thing in order to judge a researcher, in order to judge a scientist or engineer. Okay, I think I will just quickly go through this because we are close to the end. So as we have seen, there are 3 kinds of indices that we need to use for 3 types of entities. For journal articles, we have citations. So the articles, you can tell this article received this many citations. So if it receives more citation, then you can claim that this is considered to be a good paper. As for authors, we obviously have H index, but in addition to that, we also have average number of citation per article, total number of citation, which tells us the quality, total number of papers, which tells the quantity. So sometimes all of them are considered, but one single index, which is H index, give you some indication of both quality and quantity. As for journals, we have impact factor, which is very widely used, but now we know we can also define H index for a journal as well. Some journals also claim this. So I think we are towards the end and we have a few seconds left today. I will do it quickly. So you now know that many papers are published every year, but more than 50% are never cited by anyone. And this is a bad situation. And we don't want to be in this situation. We want to write a paper which is of so high quality that other reads it and then other use them in their work, and then they cite our work. Because as a scientist, the criteria that people will judge with is the H index, is the citation. So we need to have those. And there are three most important databases for us. And out of them, WOS is the most prestigious, is the second prestigious. And we also use Google Scholar, it's free. And sometimes it gives some fair indication of the quality of the researcher, but it is not so rigorous. So you have to use Google Scholar a little bit cautiously. Then we talked about impact factor. This is mainly for journals. So when you publish in high impact factor journals, you can claim that your paper is of good quality. We also know that we can categorize journals in terms of quartile in WOS, and our target should be to publish in Q1 journals, which is top 25% journal in that particular quartile. And then we have H index. Basically, it shows the quality and quantity of a researcher at the same time. So an H index of 10 means you published at least 10 papers which earned a citation of at least 10. And that is widely used, although it has got some limitation. For instance, I've shown you a very big limitation that it can have. So it cannot catch the quality of Stephen Hawking compared with other theoretical physicists. I think with that, I'm done. So I'll be here for a couple of minutes if you have any question. Any question from your side? Things are not clear. If not, thank you very much, and I will see you tomorrow.